We present secondary mathematics for Form 1. This is Program 1 of Term 2. Our strand today is volume and capacity. Our substrand is volume of cubes, cuboids, and cylinders. During the program, you will be required to take short notes and answer questions. Welcome to the program.
Hello Form 1 learners. I'm Teacher Maura. In today's class, we are going to discuss volume of cubes, cuboids, and cylinders. With me are 3 Form 1 learners. Let them introduce themselves.
Hello viewers, my name is Manu.
Hello viewers, my name is Mutua. Hello viewers, my name is Lulu.
In our previous lesson, we learned about area of regular shapes. So today, we are going to learn about the volume of cubes, cuboids, and cylinders. Learn, what do you understand by the term volume? Yes, one.
Volume is the total amount of space occupied by a solid object.
Correct one. Volume is the amount of space occupied by a solid object. The SI unit of volume is meters cubed, denoted by small m cubed. We also have other units of volume, other units, which include, we have millimeters cubed, decimeters cubed, decameters cubed, etc. Can you give examples of regular solid? Yes, Mutua.
Examples of regular solids are cubes and cuboids.
Very correct, Mutua. We have cubes, cuboids. Yes, one.
We also have pyramids, cones, and cylinders.
Pyramids, cones, and cylinders. Excellent one. All those mentioned are examples of regular shapes. Now let's focus on volume of cubes, cuboids, and cylinders. Let's start with the volume of a cube. A cube is a regular shaped object whose all sides are equal. As you can see in our chart, it's a cube. All sides are equal. Set about f for length. Its formula is given by length multiplied by length divided by length to give you length cube. So let's visualize this with an example. So an example. Find the formula, find the volume of a cube whose length is 5 centimeters. First, from our formula, volume is equal to length cubed. And where length we are given as 5 centimeters. So our volume will be equal to length times length times length. Replacing our given length is 5 centimeters. We have 5 centimeters multiplied by 5 centimeters multiplied by 5 centimeters. Where we get 125 centimeters. Find the volume cubic. Try this out. Find the volume of a cube is 20 centimeters. Whose length, find the volume is 20 centimeters. Find the volume of a cube whose length is 20 centimeters. Yes, Deori?
The volume of a cube is equal to length cube. Given the length as 20 centimeters, therefore the volume will be equal to 20 centimeters multiplied by 20 centimeters multiplied by 20 centimeters, which will be equal to 8,000 centimeters.
That's correct, Deori. Now let's shift our focus to volume of cuboid. Let's focus on the volume of cuboids. In our chart here, we have a cuboid. Was just a cross-section area of a rectangle, which is length times width. Then we have a height. So from the chart, the volume is cross-section area times height. Our cross-section area is a rectangle whose has length times width times height. Let's visualize this with an example. When the volume of a cuboid whose length width and height are 9 centimeters, 8 centimeters, and 7 centimeters respectively. Solution. From our definition, the volume of a cuboid is equals to cross-section area inside, where I have length times width times height. Replacing our variables, where length we have 9 centimeters, width we have 8 centimeters, and our height here is 7 centimeters. We get the calculation we get 504 centimeters cube. So now, try this out. Find the volume of a cuboid whose cross-section area is 120 centimeters square and its height is 10 centimeters. Try that out. When the volume of a cuboid whose cross-section area is 120 centimeters square and its height is 10 centimeters. Yes, Mutua.
So from the formula, which is cross-sectional area times height, we can replace our cross-sectional area to be 120 times 10, which is the height. Then we get 1200 centimeters cubed.
1200 centimeters cubed. That's correct, Mutua. Now let's try this another example. When the volume of a cake whose inside is 20 centimeters long, 50 centimeters long, 15 centimeters wide and 40 centimeters deep. Let's try this out.
From the formula, the volume of a cuboid is given by the length times width times height. The length in our case is 20 centimeters, the width is 15 centimeters, and the height is 40 centimeters. The volume of the cuboid is given by 20 times 15 times 40, which is equal to 12,000 centimeters cubed.
Awesome one. Now let's look at the last problem. We use a cylinder. From our chart here, the volume of a cylinder is given by pi r squared height. Pi r squared height is derived from we said volume is equal to cross-section area multiplied by height. In our case here, our cross-section area, which is visible to us, is the circle. The area of a circle is pi r squared. Here denoted by pi r squared. Replacing it with cross-section area pi r squared multiplied by the height, which gives us pi r squared height, which is our volume of our cylinder. Now let's do an example to visualize the formula. Find the volume of a cylinder. We find the volume of a cylinder. Volume of a cylinder whose radius 14 centimeters and a height of 27 centimeters and a height solution part. For you to be able to solve this problem, first you need to draw a sketch. You have a cylinder whose radius, our radius here is given as 14 centimeters and the height is 27 centimeters. So from the formula, volume is equal to pi r squared height, where the pi is always given by 22/7. The formula for volume is equal to pi r squared height. Replacing the variable, half pi which is 22/7. R squared is 40, that means 40 multiplied by 40, and our height we have as 7. So we have volume is equal to 22/7 and 14 and 14 and 7. By 7 here we 1, 2. Of 22 multiplied by 2 multiplied by 14 multiplied by 27, we get 16,600 centimeters, because it's volume and you know the size of volume must have a cubic equals cubic. Now learners, try this out. Find the volume. Find the volume. Find the volume of a cylinder. Cylinder whose diameter is 28 centimeters and has a height of 10 centimeters. Find the volume of a cylinder whose diameter is 28 centimeters and has a height of 10 centimeters. Yes, theory.
Given the height as 10 centimeters, the diameter as 28 centimeters, we can find the volume of the cylinder by first dividing the length of the diameter by 2 to obtain the radius as 14 centimeters. Now, substituting to the formula, volume is equal to pi r squared multiplied by the height. Volume equals to pi r squared multiplied by height. Pi is equals to 22/7 multiplied by 14 times 14 times 10 centimeters. This will be equal to 6,160 centimeters.
That's correct theory. When given a diameter, first divide by 2 in order to obtain radius. That's good. Now learners, in some cases, the question on cylinders may not be brought directly. They may be in some cases ask you to find the height, in some cases find the radius. Let's look at case 1. Case 1, where you are asked to find the radius. So for example, find the radius of a cylindrical tank whose volume is 1540 centimeters cubed and has a height of 10 centimeters. Find the radius of a cylindrical tank whose volume is 1540 centimeters cubed and has a height of 10 centimeters. You are asked to find the radius. So the solution will be, we are given our volume is given as 1540 centimeters cubed, the height of 10 centimeters, so we are supposed to find the radius. So from our formula, volume is equal to pi r squared h. From our formula, volume is equal to pi r squared multiplied by height. So replacing the variables that we have, it will be equal to 1540 equal to pi, which is 22/7, multiplied by r squared, we don't have the value of r, multiplied by height, which is 10. For you to remain with r squared on one side, the other values you should bring them on this side. So it will be equal to 22/7 times 10, it will be equal to 220/7, r squared is equal to 1540. To remain with r squared on one side, you should multiply by the reciprocal. So here you should multiply by 7 over 220 on both sides by 7 over 220. So on this side, r squared remains. This side, by calculation, you will get 49. Since we want the value of r squared, in order to get the value of r, we should find the square root. So the square root of r squared, square root of 49. So here you get square root of 49 is 7, and the square root of r squared will be r. So your answer will be r is equal to 7. Our units that we used to are centimeters, so it will be centimeters. Another example. Bring the length, for example, length of a cube. Question will be the length of a cube. Find the length of a cube. Whose volume is 15,625 centimeters cubed. Then give your answer in meters. our solution part. Solution. First, draw a cube. Cube as you don't know the figure of this. We are also are equal. This one you see is L. The volume V1 volume equals to L cube. But in this case, given the volume, our volume is equals to 15,625 millimeters cube. So we have to find the length of one part since because of the standard equal. So equating in the formula, we have 15,625 centimeters cube is equals to L cube. Thank you. So for us to remain one length, we should find the cube root on both sides. Root on both sides. Let's reverse this L cube. Our cube root will be cube root of 15 of L cube. Cube root of 15,625 centimeters cube. What's cube root of L cube? Yes, there will be.
Cube root of L cube is L.
Yeah, the cube root of L cube is L. So L is equal to and the cube root of 15,625. Yes, it was.
The cube root of 15,625 is 25.
Alright. The cube root of 15,625 is 25. But since our unit in centimeters cube will be 25 centimeters. That's the first part of the equation. Then the second part of the equation, you are asked to give your answer in meters. We know that how many meters give you, how many centimeters give you 1 meter? Yes, 1
100 centimeters gives us 1 meter.
Yeah, 100 centimeters is just 1 meter. But in this case, up 25 centimeters, about 25 centimeters. What we do, we cross multiply. It will be 1 meter times 25 centimeters divided by 100 centimeters. What do we get? Centimeters cancel. So you have 25 100 meters. What is 25 divided by 100? Yes, there will be.
25 divided by 100.
Yeah, it's 0.25, correct. 25 divided by 100 0.25. But now our answer is meters. Now, let's look at another example concerning cuboids. Another example, find the volume of the cuboid below. measurements are given as height. Height is equal to 6 centimeters. So here in example 5, you have been asked to find the volume of the cuboid below, where the measurement of length you have been given as 10 decameters, width is 1115 centimeters, and a height of 6 decameters. So the solution part, as you can see, the measurements here are not uniform. You have decameters and centimeters. So we should make it uniform by changing the value of the width, which is in centimeters, to be in decameters. As you know, here have been given as 1,115 centimeters. So we should change this to decameters. How many centimeters make 1 decameter? Yes, they will.
1 decameter is equal to 1,000 centimeters.
Correct. 1 decameter is equal to 1,000 centimeters. So we want to convert this 1,115 centimeters into decameters. So in the centimeters, I will come into place 115 centimeters. What about 1,115? So we cross multiply. So it will be 1 decameter times 1,115 centimeters divided by 1,000 centimeters. Our centimeters and centimeters cancels. So we get decameters divided by 1,000. 1,115 divided by 1,000. What do we get? Yes, it's what?
We get 1,115 divided by 1,000 is 1.115.
Yeah, correct. 1,115 divided by 1,000 get 1.115 decameters. Now back to the formula for finding volume of a cuboid, which is volume is equal to length times width times height. Replacing the variables, our length here we have as 10 decameters. We have as 10 decameters. Our width we have it here 1.115 decameters, and our height is 6 decameters. What do we get? 10 multiplied by 1.15 multiplied by 6 decameters. Yes, Mwangi?
10 decameters times 1.115 decameters times 6 decameters gives us 66.9 decameters.
Correct, Mwangi. So we have 66.9 decameters cubed. And that would be our volume of the given cuboid. Now, let's look at another example involving cylinders. This one mark our last example. Find the radius of a cylinder whose volume is 20,790 meters cubic, and height is 15 centimeters. So in this question, given a clue, use pi is equal to 22/7. The solution part, the first step, the first step is to draw the cylinder. So we come here and draw our cylinder, a sketch of the cylinder. Here we don't have the radius, but our height is 15 meters, and the volume you've been given as 20,790 meters cubed. Who can remind us the formula to find the volume of a cylinder? Yes, Dewi.
To find the volume of a cylinder, volume is equal to pi r squared multiplied by height.
Correct. Volume of a cylinder is given as pi r squared multiplied by height. In our case here, we've been given the volume, but we've not been given the radius. So we can make radius the subject, where we get r squared, which will be our volume divided by pi times height. Replacing the values to equate with r squared, our volume is 20,790 meters cubic divided by our pi, which is 22/7, multiplied by our height, which is 15. What do we get? Yes, Mutwa?
20,790 divided by 22/7 times 15 meters is 441.
Correct. Equal to 441 meters square. This one you are equating it with r square. So we have r square, which is the same as 441 meters square. Find the value of radius. What do you do? Yes, one.
We square root on both sides.
Yeah, we find the square root on both sides. Where we have square root of r squared and square root of 41 meters squared. What is square root of r squared? Yes, theory.
The square root of r squared is r.
Yeah, correct. Square root of r squared is r. And square root of 41 meters squared. Yes, Mutwa.
The square root of 441 is 21.
Very good. Square root of 441 meters squared is 21 meters. So that marks the end of our class today. So today we have learned about volume of cubes, cuboids and cylinders. We also learned about volume, which is the amount of space occupied by a solid object. And we've also learned about the SI unit of volume, which is meters cubed, and also other units to measure volume, which include the millimeter cube, the centimeter cube, millimeter cube, and many others. And also we've learned a lot of examples we've solved a lot of problems involving cubes, volume of cubes, cuboids, and cylinders. So between now and our next class, we have an assignment. First assignment, you should read ahead the volume of graph terms and volume of pyramids. And also, try to calculate this one. You find the volume. Find the volume of a cube whose length is 26 centimeters, and give your answers. Give your answer in SI units. And we'll stop at that point for today. Let's meet in the next class. Thank you.
You have been watching program number 1 of term 2 in the secondary mathematics for form 1. Our strand today was volume and capacity. Our substrand was volume of cubes, cuboids and cylinders. The program was written by Victor Mwangi, Mary Mutua, Ann Theory, Francis Mwaura and Brian Kerich. It was edited and produced by Brian Kerich. Your TV teacher was Francis Mwaura and TV pupils were Ann Theory, Victor Mwangi and Mary Mutua. The technical operator was Brian Kerich. This program was produced in conjunction with the Department of Educational Communication Technology, Kenyatta University. Thank you for watching the program. Till next time, goodbye.